Welcome to the Storage Security Summit 2022 talk about Symlink Races and how to deal with them. My name is Volker Lendecke, and first a very few words about myself. I live in Germany, in Göttingen. I am co-founder of SerNet GmbH. We do a lot of development in Samba. My own history with Samba started in 1994. I'm so a pretty early Samba team member. And I focus on the file server and all the infrastructure we need for this. I am one of the co-authors, co-designers of Clustered Samba. And I also take a look at Winbind whenever it's necessary. My colleague Stefan Metzmacher, he is the one who in SerNet focuses on the Active Directory controller. So when you have questions about Active Directory controller in Samba, talk to Stefan. So what is a Symlink race and why do we have to care? The second question is pretty easy to answer. If you do a simple search for Symlink in the CVE database, the common vulnerabilities and exposures database of Mitre, you will see that 1,354 records match the search for Symlink. And the first one that I see, it was searched yesterday, Trend Micro Antivirus for Mac has a Symlink problem. And this is pretty typical if you have programs running on your computer under different privileges. And an antivirus engine typically has full system privileges. And if this engine has a Symlink problem, anything can happen. And what can happen here, as you can read, is it's a privilege escalation. So an attacker can become essentially system, root, whatever. He can take over your system. So there is something going on, but what is going on? I would like to describe Symlink races with a little example. Imagine I have a blog. I don't, but imagine I have a blog and I want to publish cat photos to my blog. What I do first is I go to my file explorer, Nautilus in this case. I browse my directory hierarchy, and what you can see is I have home, photos, pets, cat, and 2 cat photos. What I then do next is I copy the full file path /photos/pets/cat 01.jpg into my browser, and then I press upload. So where's the problem? If we look at my directory hierarchy, I have 2 subdirectories of photos. One is my pets, cat 01, the blue one that I want to publish. However, I also have had some communication with my insurance lately, and I also have 01 and 02 in my insurance and car folder. And so now I publish /photos/pets/cat/01, and this is the cat photo that I want to publish, a cat playing with a little animal. However, let's look at what happens. I publish my cat photo, and this is a multi-step process. First, I browse my directory hierarchy, and I check and I make sure that photos pets cat 01 is a cat photo, actually. Then a few seconds pass by, and an attacker has time to place his attack. Then I press upload. The attacker, in the meantime, replaces 01.jpg with what Linux calls a symbolic link to my latest communication with my insurance. And the command the attacker sitting on my computer issues is ln link -sf, and you can see what he has to issue. He links the second photo of my car with what I want to publish. And now my directory hierarchy looks like this. What you can see is I still have an entry in the cat directory called 01.jpg, but it is not the file anymore that I want to upload. It is a symbolic link to a completely different place in my directory hierarchy. It points at 0.202.jpg in my insurance communications. So I publish my cat photo. I believe I published my cat photo. However, what I actually publish is well, this is not my cat photo. And I mean, this is not really bad, but this could have been your password StockX, where you store all your Amazon credentials and your Google Mail password and so on. And in the best case, it's encrypted, but more than it is, it's not encrypted. So what do we do? Linux can protect me against this kind of attack. How do I open a file in POSIX? There's a C language function called open, which is used to open a file. I have to give certain arguments to that function. Of course, I have to give the file name, but I can also give a few flags to this file name, to this function. And one of the flags that I can give to this function is "oh-no-follow." What does it do? Now a quote from the main page. If the trailing component of path name is a symbolic link, then the open fails with the error eloop. What is the trailing component? Let's go back. It is the last component. It is the 01.jpg. That's the trailing component. And if this, as you can see, is now a symlink, we get an error. So in this case, my application pressing the upload could get an error message. And yeah, the user will be notified, hey, something bad has happened. However, this is not the only attack an attacker can play. This is not the only trick an attacker can play on. Because, another quote from the man page, symbolic links in earlier components of the path name will still be followed. And this is what this means. This is a different attack an attacker can play on. What it does, it replaces the cat subdirectory, it renames it to cat.old, and replaces the cat subdirectory, the green one, with a symbolic link to my car directory. And now if I want to upload photos pets cat01, I really upload photos insurance car 01. And well, this is not really better. Also, this could have been your passwords.txt. How do we mitigate this attack? What we can do in POSIX is we can fully change directory into cat. So what I do is I change the photos pets cat, indicated by this little yellow person there. And if I sit there, nobody can remove me from there anymore. What I then do is, in a second step, I do a check that I'm really in photos pets cat, that this is a subdirectory that I want to publish from. That is not the car directory on the left-hand side. And now if I open 01.jpg with oh-no-follow, both cases, first 01 is a JPEG, 01 JPEG is a symlink, and me getting moved to cat.old is mitigated. Because if you look at what happens if the attacker plays the same trick as it did before, it renames cat.old, but it moves me with the rename. So I'm still sitting in the same directory. It's called different, it has a different name, but open01.jpg with the oh-no-follow flag still references my cute cat playing with the animal. The problem with this approach is, if we look back a few slides, here we are, sorry. If we look back, these are 4 steps. And in particular, the second step, check I'm really in photos pets cat, can be very expensive. So in POSIX, we have another way to mitigate this attack. And this is the Openat-Call. What is the Openat-Call? What I can do is I can take a handle on this cat subdirectory and have it represented by a number. So what I do is I do my 4 expensive steps just once. And if I want to publish 01 and 02, both cat photos, I only have to do these 4 steps once. I change into this directory, I check everything there, I take a reference, the Linux kernel gives me the number 42, or any number, as a reference to this subdirectory. And what I can then do is I can not open a file, but I can open-at a file. And you can see the function call down below. It's open-at 42, the reference that I got. It's 01 in this directory with the oh no follow flag. And even if I now get renamed, the 42 still refers to this subdirectory where my cat photos are. Just to wrap up, my Symlink Races from 30,000 feet. Path and POSIX are prone to input validation problems, like SQL statements, like anything that comes from the user, that comes from any application. It needs to be checked very, very carefully. A Symlink race is a time of check, time of use, TOC2 problem. I did check with my file explorer that photos pets cat actually contains cat photos. But then when I pasted the path into my browser to do the upload, something got changed behind my back. And this is the time of use. Sanitizing paths is possible, yeah, but nobody does it because it's tedious and it can be slow. And the current status in Samba with version 4.15 is that many playthroughs in Samba choose this change dir check, open, change dir way, the 4 expensive steps, which means that for metadata operations, Samba is a bit slower than it used to be in 4.12, for example. We are working actively on passing these directory handles, the 42 from the last slide, everywhere to make this fast again. Also in the Linux kernel, there's work ongoing to make sanitizing paths much easier. For example, the Linux kernel now has an Openat-Call call, which you can not only give the oh no follow flag, but also say resolve no symlinks. Remember the open call said that path components before the last pass were still following symlinks. If you use Openat-2, resolve no symlinks are allowed anywhere, and then you can do more expensive checks. And I believe I have already read that there will be a mount option in Linux completely disallowing symlinks. And this would be a great thing. So everybody has Symlink races. They can be mitigated, but careful programming is required. Thank you for your attention.